the last chapter, lecture, hallelujah, they say, in this block. There'll be some more in the next block. A lot more in the first couple of weeks at least, a lot more doing things. This block. This block, this course, this class, this block, we go by blocks, ends next week. Huh?
You're going to be using the same books next
We're going to be using the same books next time. Identify a variety of uses of WANs. WANs, well, what do we generally use WANs for? What do you use a WAN for? Outside, you get on the internet, basically, right? It's a wide area network. Now, but there are other wide area network uses. For instance, there is a wide area network between this campus and the Virginia Beach campus, so that we have direct connectivity. So we use a wide area network. And we looked at the router in the NOC. Yeah, there's a router there. And it divides the traffic. Some of the traffic goes directly to Virginia Beach. Some of it goes to the Richmond campus. That's where our internet traffic goes, and gets put back together in a bigger pipe. They bought some 100 megabit per second connections, and what they did was then divide those 100 megabits connections into 10 megabit connections to go to the various campuses. They have to be put back together someplace. We're on the one that gets put back together in Richmond. And if you do a trace route, you'll see that you wind up with routers in Richmond, and then one of the places that you go out of. Variety of uses. The difference between WAN topologies, including their advantages and disadvantages. The WAN topologies, honestly, are not going to be radically different than the LAN topologies. We're going to have the stars and the bus sort of arrangement, daisy chain sort of arrangement. So put them together that way. WAN transmission and connection methods, including the PSTN, really fancy term for the telephone system, publicly switched telephone network, sometimes called POTS, plain old telephone system. ISDN, which some of you may have. T-carriers, ISDN you won't have. DSL you might have. ISDN is one that, as far as I can tell, the only reason it's still in these things is so that they can ask. It's got so many components, you can ask a lot of certain test questions about ISDN, something that really never ever took off. T-carriers, T1, T2, T3, T4, how fast do they go? T1 is always, oh yeah, it's really good. T1, 1.544 meg. That's slower than cable, isn't it? Yeah. Cable's like 20 meg down, 768 or something like that up. A T-carrier is going to be, you get the same rate up and down, so it's going to be symmetric. And that's one of the reasons that businesses buy them, so that you get the same upload. If you have a website, you get the same out as you get in. Cable, the stuff that we buy, we mostly get things, right? Most people are not running a website in their house. For one thing, Cox blocks port 80, so.
Do they really?
Yes, they do really. You have to use a different port, like 8080, in order to do that. They block a lot of the well-known ports, including Telnet, believe it or not, unless you have a business account. And pay more, get more. Pay more, get more. T-carriers, broadband cable, SONET, wireless internet access technologies. To me, the wireless technologies, as we become more and more and more mobile, are really kind of interesting. The advances made there, WiMAX is the one that they talk about in here, 802.16, which has got a theoretical gigabit. Gigabit wireless is pretty darn good. There is a wireless provider in the Roanoke Valley, B2X. They don't go gigabit speeds, and they ain't cheap. But you can get wireless internet in most of Roanoke. And in some of the outlying areas, if you're someplace like Mr. Geis is out in the middle of nowhere, you have trouble getting internet connection. He tried cable. He tried satellite. He didn't have cable. He tried satellite for a while. Really expensive, really slow. He wound up with B2X. As long as you can see one of the mountains, if you can see one of their antennas, you can get it. So, but things like that are available for what they call the last mile. Last mile is not really the last mile. Last mile is the connection between the trunk and your house. Cable, the last mile. The last mile is from the box, the cable box into your house. It's going to be the last mile. This is the last mile wireless. Compare the characteristics of WAN technologies, including throughput, security, and reliability, and that's mostly, there's a table that has a lot of that. Software and hardware requirements to remotely connect to a network. Remote connection, and that just kind of got in here, but just because of wide area networks. Remote management would allow us to manage remotely, obviously. And you've seen me do a little bit from this room to the server over there, just a remote desktop connection. The advantage why you want to do that is if you live in a Callaway or someplace far away, and then all of a sudden the boss calls you up on a Saturday morning or a Sunday afternoon when you get sit down to watch a football game or whatever you're getting ready to do, I need my password reset. Would you rather be able to take the 5 minutes and get on remotely and do that, or take the 2 hours to drive in, reset the password, the 3 minutes to reset the passwords, and then drive back? So remote access is a big deal. Internet, largest WAN in existence. Are there other WANs? Yes, WAN is a topology, a technology, protocols that we use. Wide area network. We do have a wide area network. There's a connection between, like I said, this building in Virginia Beach and all the other campuses in Virginia Beach. So they create wide area networks. One of the reasons they do that is to protect you, because all of your financial aid information, you don't really want that on the internet, do you? No. So it goes.
Depends upon if they give you a check.
Give you a check fast enough or not. They'll take your check fast enough, but not only do they have a dedicated connection, but they also use an encryption. They use a VPN that goes from here to there. So it's kind of a double protection. Dedicated connections become more difficult to get information off of. They become, we talk about VPN, and we'll talk about VPN briefly here, but VPN, virtually private network. What's the difference between it and a real private network? A real private network is something that only two endpoints are connected with. It's not a shared media. It's not a shared resource. Shared media is like we have here. It's a shared media, isn't it? Because we have Ethernet, switched Ethernet, but everybody's using the same wire, basically. WANs and LANs are similar in fundamental ways. Different at Layer 1 and 2. Mostly Layer 2, where the protocols are defined. Some of them actually get definitions there. They're going to talk about one. They've got one in here called X.25, which actually did kind of sneak into Layer 3 also, but it's not really used anymore. We use a souped-up version called Frame Relay to do it. WANs typically send data over publicly available communication networks, network service providers, dedicated lines. How are we going to do that? So the dedicated line, like from here to Virginia Beach, is a dedicated line. They pay all the bills, so they buy a dedicated connection between us and them, between Greensboro and them, between Raleigh and them. I mean, running these things gets to be kind of expensive. Just thinking about what they pay for internet access and just paying for connectivity does those things. So dedicated line, service providers. Connection between WAN sites, points. We have to have the same protocols at each end so that they can communicate with each other. And that's typically, honestly, going to be dictated by the ISP, whatever you buy. It's just like, how many of you buy cable? Cable internet. Mm-hmm. Some people buy DSL. Everybody buys cable in here. But some people usually have somebody has DSL. Somebody buys DSL and say, why you got DSL? Because I can't get cable. Why you buy satellite? Because I can't get cable, I can't get DSL. You buy basically what's available based on your price point and speed requirements. And what each of those. What's that?
Why don't you move?
That's expensive. Moving is expensive. Differences in LAN and WANs. A LAN topology, a WAN topology. These are similar. This is a point. The Charleston one is a point to what's called a point to multipoint. But in here we have a mesh arrangement, not really a mesh, a sort of a mesh arrangement. We actually just kind of have a ring, don't we, with one in the middle. Multiple connectivity points, and that's really what you want if you have a large network like that. We don't have that connectivity from us to them for real. So when that, and it's very rare, but when that line goes down, that line's down. And lots of really strange things happen when that line goes down. The phones go out of service because they're voice over IP. Some services from the beach aren't available, can't update the databases, things like that. So what kind of redundancy do you want, do you need in a wide area network? And the more redundancy you have, obviously, the more expensive it's going to be. How much bandwidth do you need? How much are you willing to pay for? WAN topologies, the details, the distances, the number of users, and how much traffic are you going to have in each of these things. Although I'm not sure that in today's technologies, the data rates actually are pretty high. You don't really worry about T1s. Nobody really talk about T1s anymore, do they? For real? T1 is 1.544 megabits per second. Not really all that fast in the things that we're in the numbers that we're used to hearing. But what do you want to buy? How much do you need is what we're really talking about there.
Oh, like I was saying, over at Sears, they use T1.
Yeah. Use T1.
Just they have one T1.
One T1, and they feel that it's sufficient. And all people, voice really takes very little. Voice is tiny packets. We're talking Ks. We're talking K for voice. Voice. The issue with voice is delay, and the consistency. I call it delay and jitter. How much is the delay? You get echo because when you get different delays between the different packets is when you start getting echo with those things. So that kind of thing, consistency becomes you can get that with your cell phone, yeah. It's a similar thing, yeah, but becomes atmospherics. I think most of that becomes atmospherics with those things. Connect sites via dedicated. Usually high-speed links don't have to be high-speed links, and high-speed is a term that means different things to different people. Obviously, at Sears, 1.544 is a high-speed, right? But we don't consider that a high-speed link here. We're 10 meg, that's pretty good. 20 meg, that's pretty good. If we could get a gigabit per second on a wide area network, that'd be really good, right? When you get to the SONET, the backbone, you're talking really, really high speeds because you got a lot of data to go in those things. Special equipment, when we were over in the NOC, don't know if everybody looked, but pointed out that's the fiber cabinet. Yes, it requires special equipment in order to get onto that thing. Big, huge box over there is where all the fiber signal comes in and goes out of the building. Not capable of carrying non-routable protocols. Wouldn't make much sense to put a non-routable protocol on a wide area network, would it?
Yeah, because it's going to be routed somewhere.
But not if it's non-routable, because a wide area network needs to be routed, right?
Right.
The routable protocols, if you run into, I'm going to say this, an IPX system, you probably can do it, although I believe that Cisco, in their newer routers, has actually taken support for IPX out. IPX is a proprietary network protocol that I seriously doubt that you'll see anymore because the 312, and it goes with the network 312, and they're in the 6s or maybe 7 somewhere. I think they're in the 6s. 6.5 is the last one that I saw. Was a routable protocol. Non-routable protocols net buoy. And how far do the non-routable protocols go? Broadcast protocols go all the way to the router. Because they're not routable, they can't go to the other side of a router. A wide area network, the starting point is typically going to be a router. Because how else are you going to make it wide area? You got to get those protocols. You got to communicate. The router is going to be the device that transforms, I guess that's a good word for that, our Ethernet protocol because we're running Ethernet into a wide area network protocol, a frame relay, ATM, asynchronous transfer mode, something like that, so that it can then be broadcast, transmitted, broadcast bad term, right, because that means it goes to everybody, transmitted via a unicast over longer distances. Bus, similar to the LAN topology, may be the best option for organizations with a few sites and the capability to use dedicated circuits, make it possible to transmit data regularly and reliably. We can have a ring. A ring is going to give you some redundancy because if it doesn't work in one direction, it might work in the other direction as you go around there. Somebody's going to be missing something somewhere, but a ring gives you capability maybe to go in different directions. Counter-rotating ring would be a good thing. 2 rings, one going in each direction, would give you that redundancy, practical for a few locations. I don't know why it didn't want to give me my picture here. Ring topology, is that what this one says? Bus topology. This is exactly kind of sort of what we saw in a true bus. A true bus is going to be everything connected one to the other. A true bus is going to be on a piece of coax with T's, and if somebody breaks it, then we've lost that connectivity.
That's everybody, because it breaks one line.
That's in an Ethernet bus. That really wouldn't be the case here because we would just lose these connections. But if we lost the T1 here in the center, then you got the left side can communicate and the right side communicate, but they can't communicate with you. If we brought this thing around, I know here we go with these markers again, right? If we brought some sort of a, well, I like that, huh? Guess I didn't get it marked. Bring it around. Now we got a ring, right? And we could have if we move one of these guys down, we had something at the center. We could create a star if we take this guy out. Could we create a star with these things?
Sure.
But only if I can erase the ring, right? A star will say that, let's say this is the headquarters. A star we could connect to each of these. We could create some redundancy if we then did some other things. Could we, and let's just fool around with this one a little bit here. Could we create a mesh? And that's a term I think I haven't used yet. What a mesh is, everything's connected to everything else. So we got Madison here connected to Main Street, or South Oak connected to Main Street. We have to connect here, and we have to connect here. So now this guy's connected to everybody else, right? Now we're going to go in here and connect this one to everybody else. Well, we're almost already connected to the rest of them, aren't we? We just need to have one connection in. How about this guy? Is he connected to everybody else? Yeah, he's there.
He's connected to everybody.
Is he connected to everybody else?
Yeah.
So that if any one connection goes down, we have redundant paths. But that's going to be an expensive arrangement, especially as you get more, and as you get more and more and more, it becomes just what I always call a mess. Say again?
Talking about running cable and sticking up streets.
Actually, are we talking about running cable and tearing up streets? Now, they're not going to allow you to do that. No. That's what we have ISPs for. This is something that probably can be a reality in a frame relay world, but it's still going to be expensive when you do that because you're going to buy all those connections one to the other. So can we? There are different, and we've kind of covered now. We've covered the topologies, wide area network topologies, kind of, sort of, anyway, haven't we? Because that's what you can have is a ring, a bus, and a star. True? Or those are Can you think of any other topology for real? We'll go through here. Now we have the ring topology. Just exactly what we did. Star, separate routes for data between any two sites, just like a star. What's the problem with any star? If your central goes down, everybody's down. Same thing here. If we had a star, and the star is going to come back to a central location, usually a headquarters. And that's what the Virginia Beach or the ECPI of Tidewater Incorporated, our company, has. They have, at Virginia Beach, they have this thing, whatever, that goes out to the various campuses. The other campuses really aren't connected to each other. They're all connected to Virginia Beach. Could they make them routable? Yeah, but they don't, because it's not really necessary, because there's not anything that we need to get from Greensboro or something like that. If there is, they can host it at the beach, so that it simplifies their routing problem a little bit. But they have a star. So if the center of the star goes down, our whole network goes down. That part of the network goes down. One of the issues with some of these things, is there any perfect solution? There is no fail-safe solution for these things, unless you got an awful lot of money to put in there. A mesh, every site's connected to every other mesh, and a mesh is the one that's going to be fault tolerant. Typically, you're going to have a partial mesh where you connect your high speed, your high value locations together, and then everybody else is kind of on their own. Full mesh and a partial mesh, again, going to be expensive if you do that, because you got to buy all those connections. Tiered sites are connected to star and ring formations, interconnected at different level. Got some flexibility with these things. So this would be the star topology. Nothing dramatic about that. We've already kind of looked at that one as we go through this thing. Full mesh and a partial mesh. Full mesh over here, we looked at a full mesh. Partial mesh. See, our guys out here in Indianapolis aren't very important, are they?
Hanging in the wind.
Hanging in the wind. So if they go down, they're down. Everybody else, if they go down, if one of these goes down, there are alternate data paths. If we broke this one, we could get there this way, right? And if we broke this one,
You talk about if one connection goes down, yeah, everybody can still communicate with everybody else. But wouldn't that maybe cause another connection to go down if the traffic was?
If the traffic's too much, it'll cause it to slow down, but probably not go down. It might slow things down, but and I guess that becomes just like, again, back to the highway situation. There are multiple ways to go from one way to the other, but the bridge got closed or some got flooded and everybody goes the other way. Yeah, it doesn't make the other one stop, but it does slow it down, depending on how much traffic that you would have in any of these things. Except for our friends here in Indianapolis. If they go down, they're down.
Did you overload a switch and crash it?
Yes. And what you do when you overload a switch, a layer 2 switch, it goes into hub mode. That's called MAC flooding. So that if you want to try to hack something, because we talked about you only see the traffic to you in the broadcast traffic. What if I wanted to see everything? I go and flood the hub. Flood it with MAC addresses. Once the MAC table becomes full, it becomes a hub.
One way in, one way out.
One way in, one way out. Are there ways to stop that? Yeah. And that's what the security classes are about. How can you configure it? Can you make your network invulnerable to everything, anything? No. Can you make it more difficult? Yeah. Kind of like, in my favorite stories, the two guys that kind of illustrate this, two guys out in the woods come on a bear, and one turns to the other and says, we got to outrun that bear, and the other one says, no, I just got to outrun you. If you make your network more difficult to get into than the next guy, where do you think they're going to go?
To the next guy.
To the next guy, unless there's something really specific on your network that they want.
Hackers are funny people, though. They like a challenge, you know.
Well, they do, but sometimes they just, the ones that want the challenge, honest to goodness, don't do that much permanent destructive. I don't think permanent destructive. They do defacing and stuff like that, and that's pretty easy to fix. They don't steal 16 million credit cards. Guy wants to steal 16 million credit cards. He's gonna, yeah. So how are they gonna do this thing? There are all sorts of reasons that people hack, and you're right. Some of them for a challenge, some of them for bragging rights, some of them for money, some of them just to get their name in the public on the whatevers. Some for political reasons. I mean, we got a lot of them for political reasons lately, right? Anonymous. WAN topologies are tiered. This is kind of like multiples, isn't it? Is it kind of like one of those backbones? Is it not? We have a backbone connection here going across these guys, but we don't have any redundancy between these, do we? And then we have a star arrangement with everybody else.
That's like a hybrid?
That's like a hybrid, yeah, or they call it a tiered. This is their term, tiered topology, as we look at these things. The different terms here, they're going to have some slides here in a minute, DSL T1, T3. Yeah, those are the ones there. There are other ones available with these things. PSTN, publicly switched telephone network, sometimes called POTS. You'll see it POTS, plain old telephone system. We're just using the phone system, traffic carried by fiber, copper, twisted, whatever is available, microwave, lots of different media in this thing. The protocol that you're typically going to see here, the layer 2 protocol, is PPP, point-to-point protocol. Point-to-point protocol, when you get into routers, we have a bunch of routers that have protocols that have the same name, but they're proprietary to each of the manufacturers. The one encapsulation, layer 2 encapsulation protocol that is standard is PPP. And if you are unlucky enough to have to use dial-up, that's going to be the protocol that you see, is point-to-point protocol. Usually means connecting to a PSTN line. Advantages, ubiquity. That's a great word that I had to look up one time. It means it's everywhere.
So the telephone system, the way it works, unless you have voice over internet, is really almost exactly the same as like these topologies you see with.
Yeah. Also, exactly. Topologies. They all have topologies. They use switches. Phone system uses switches, and they switch over until they switch down to your actual phone number to connect to it. Yeah. The internet itself, honestly, we have this cloud. We always draw it as a cloud. And it's always been my contention because nobody has a clue what goes on inside it. What it is a great big telephone switching network, high-speed telephone switching network. So that's what we're really using with these things. Ease of use, low cost, and the answer is low cost, maybe not, depending on whether you have to pay long distance rates or not. Low throughput, because you can go all the way up to 53 megabits per second on dial-up, right? They say 56 modems. The FCC limits it to 53 meg. That's the law. Marginal quality, marginal security. I don't know that you can really say marginal security, because when you make a phone call, it actually connects 2 points. It is a private network for that time. And when you watch a lot of these older spy shows, where's the first place they go to do stuff? They're going to go into the phone closet. Right? That's where they're going to go. The FBI still does it, but they do it with a warrant, we hope.
Well, no, they have this room at the FBI where you go in and get, I'm not allowed in there, only certain people. You go in there, you get information that's only available in that room.
Yeah.
You come back out.
Yeah. Can you see those things? But generally speaking, people are going to protect those phone closets, and that's one of the places that people really like to penetrate. That's going to be one of your security areas. Nice picture, publicly switched telephone, local loop, goes to central office. The central office is something, and they draw this really nice big building. Central office is just a type of switch. Because to have DSL, you have to be within, I think, 50,000 feet of a central office. Say, well, golly, I'm not within 50,000 feet of the central office because it's downtown someplace. It's a switch type. You have to be to do that. DSL is more popular in the western part of the U.S. than the eastern part of the U.S. because the phone systems are newer, the switches are newer. They really haven't upgraded. DSL, well, this is publicly switched, but when we get into those types of arrangements are there. X.25 and frame relay are related. X.25 is the analog packet switching used for long-distance data transmission. Not really used anymore. Frame relay is its descendant, more reliable, less configuration required with it. Flow control, data reliability, comparatively slow. When you do the Cisco course, you'll do a frame relay configuration. Set up a frame relay. It's the digital version, frame relay, digital version of X.25. Does not guarantee reliable delivery of data. Frame relay is a very popular system to use because it's one of those that if all of the bandwidth's not used, what you do is buy a minimum, whatever you absolutely positively need. If there's any excess bandwidth, you can use it. So you have a guaranteed data rate, and then if there's any excess, you can use the excess, which is kind of a good deal. Uses switch virtual circuit connections established when the parties need to transmit, then terminated after the transmission is complete. That's how we get the private network, just like a telephone system. As you do the switches down to your individual, you create a connection between these two. The switch virtual circuits do that. We don't control the frame. We call a frame cloud, which will connect point to point to point to point until you finally get there. It's kind of like, okay, I want to go to Virginia Beach, go into this slot, and that will eventually take you to Virginia Beach. So we have switch virtual circuits and permanent virtual circuits for each of these things, not dedicated individual links when we go through these things. Committed information rate's what you buy. That's how much data you actually need. If there's any access, then you can use that. Panel for the bandwidth, throughput sensitive to network traffic as we do things. And you see this just like the internet, right? Frame relay, what's going on in there? That's something that the ISP is going to control, going to manage. What you really wind up with is a bunch of frame switches that go in there. This thing uses ATM. ATM was the 48-bit cells, right? Frame relay inside it actually uses ATM in order to transfer the information. When you see those things, ISDN will say it exists, international standard. It's one that never really took off. Years ago, when we had dial-up, and a teenager who stayed on the internet all the time, you couldn't get phone calls, which sometimes is not all that bad a deal, especially when people, you get the handshakes or the data, or pick up the phone, But she called up and said, hey, and they had a special, free install for the second phone line. So called up and said, want a second phone line? What are you going to use it for? The computer? Oh, you can't use the $6.95 a month or whatever. You need the $100 a month computer line, the ISDN. Well, no, we didn't. So we finally did get that. But this is 128 megabits per second. What it is a digital phone line that are available there. It had data and it had a voice capability, B channels and D channels.
Isn't most phone nowadays digital?
Yeah, but this is an old standard. This is a very old standard.
Analog.
Yeah, you said digital, kind of yes and kind of not. Voice over IP, the stuff you get from Cox is digital. The stuff that we have here is digital, which causes some issues when you want to do a fax machine, because fax machines require an analog phone line.
Do that?
Yep.
Is there a fax machine here?
Yep, one up front. It's got a digital analog converter on it, so that you can use it on the voice over IP network, the IP voice network. So there are ways around these things, but yeah, there is one. Dial up over dedicated connections, voice calls and data simultaneously on one line. We do that with cable now. You do that with DSL now. So this is, again, an old standard. And back to, this is what I'm talking about. It's got a lot of parts. And the only thing that I can figure it's good for anymore is certification questions. The BRI is the U.S. standard. I say it's 128 meg. It is 264 meg connections here in a data line. So the B signals, the BRN here, BRI, two Bs plus a D. The Bs are where the data is actually carried. The European standard goes down here. We have 23 of these things, which is going to give us a T1 speed, 1.544 meg. When you use these things, NT1 TA, NT1 NT2 TA, terminal adapter is what these things are. It may or may not be built into the device itself if you have an ISDN device.
Like here in the United States, the FCC limits the distance on like a cordless telephone will go.
Yeah, I mean, yeah, you can actually put these things together and get a larger bandwidth if you want, but why would you do that today?
If you wanted to, say, set off an IED with the garage door open. I mean, that's why
they limit it for a number of reasons. They limit the power on the wireless access points. Can you change that? There's a number of ways to do it. The antennas, if you put a Yagi antenna up, it's going to be it's going to go a greater distance. There are some operating systems you can put on, some of them that you can control the power and bring it up, 2 or 3 or 4 times what you want. I read an article about a guy in Colorado who decided, and he lives several miles out of town, 15 or 20 miles out of town, decided he wanted to be able to see his wireless access point from his favorite bar. So he broke the law and was able to see his wireless access point from his favorite bar. But you know what the problem was?
What's that?
His laptop didn't have that big, powerful antenna to get back.
Oh, yeah.
So, yeah, these things, you can group these things together, these individual cells together, in order to do that. T-carriers belong to the physical layer. We said that these are layer 1 and layer 2. So the T-carriers are a physical layer. Time division multiplexing over the wire pairs. What time division multiplexing is, you get a specific amount of time to send your data. We went around, when you go to CSMA CD, you have access to the media until you no longer need access to the media when you do these things. It can be single channels or multiple channels, and this is a list of them. When you get up into the T4s and so on, T4, 274 megabits per second, probably talking something we use. The T1, which used to be one that is just absolutely desirable, not so fast anymore. And the number of channels, it has 24 channels. What you could do with a T1, you could actually dedicate part of it to each one. We had a T1 at one time, and I've forgotten exactly how it's split. You had some of them going to one thing and some of them going to something else. So you can dedicate part of it to different functionalities. So T1C2 for how many T1 lines you have, and then how many channels that you have in each of these. You put them together, put the channels together, 64 megabit channels together to get those speeds. Car hardware and all those other good things. On a router, is actually just a module that you plug in. It's called a T1 module. You plug it into your ISP, and then you have the adaptive adapters that you need in order to get it out onto the ISP. Wiring, unshielded, twisted pair, shielded, coax, microwave fibers, which is saying is just a little bit of whatever is available you can use with these things. Multiple T1s, T3s, and microwave fiber optic is necessary just because of the speeds. CSU, DSU, nice term to know what it is something that, and I think they say the CSU, DSU prepares the signal for transmission on the T1 line. The T1 line is going to be digital. So channel service unit, data service unit is something that you plug into in order to get into the T1. Sometimes there are standalone pieces of equipment, or on these modular routers you can get a module that plugs in. It's really pretty unimpressive. It's a little module with a RJ45 connector, says CSU, DSU, or actually says T1, I think. So the connectivity, the telephone switch, the data switch goes into the router with the CSU, DSU into the T carrier. Nothing dramatic conceptually about how these things connect together. DSL operates over the PSTN. You can buy different levels of service. Doesn't really get all that fast, I don't think. You can look and see what level of service you have, and that sometimes is dictated by how close you are to that switch that's available to you. So it allows you to do voice and data over the same wire. When you do that, you have to put filters on your telephone, and they'll give you the filters so that you filter out the data signal. So you're not listening to it like Tom was talking about earlier. Picking up the phone in the old dial-up days, and you get all that nonsense. You're going to get some data noise on these, and the filters are there to prevent that. The DSL, ADSL throughput, and this table is in the book. You can go relatively fast, but if you look at these things, the lower level, 768K, not all that expensive. As you go faster and faster, it's more and more and more expensive. When you look at these things, and everybody does their own comparison, again, what's available may be a function of what you get. But still appears to me that cable probably our best deal here anyway. I get back the splitter it shows down here. You do have a splitter that goes in. It just comes in on your phone line. Put the splitter in. The DSL modem and the telephone uses each of those things, and there should be a filter on the telephone so that you don't get the data noise on the listening to it. Broadband cable, which is probably what most of us have. Asymmetrical, symmetric and asymmetric. Asymmetric means we have a different download and upload rate. And if you do that, if you upload anything, you'll see that dramatically. Download rate, download maybe 20 megabits per second, upload maybe 600 or 700K. Symmetric means that we have the same down and up, and that's what you want in a business, is a symmetric connection. So if you're running a web server, you can send your information out in a timely manner. Cable modem, you've already done that. Hybrid fiber coax may or may not. Mostly they're going to fiber. Hybrid fiber coax is a piece of media that has both coax and fiber in it. So it is both of them together. Support the high frequencies. Distribution hub, broadband cable, different topologies. Are they actually going to be that way? Yeah. What happens with cable is we do have a neighborhood, and the cable drops. What does this remind you of? Which LAN topologies does this remind you of? Star bus. Bus is the one I was looking for, but
ring bus, I'm sorry.
Ring bus. This would be the ring, absolutely. But over here, this reminds me of bus. So what happens to these things is, for lack of a better terminology, to me, it gets caught there once in a while. The tip sticks and it sends a signal. It uses an IR to that thing up there. Yeah, but if you're the only one in the neighborhood, you get all the bandwidth. But everybody comes home at night, you're going to slow down, especially, all the kids in the neighborhood are downloading movies, right?
Well, the simple pair of bolt cutters, you could make...
Simple pair of bolt cutters. Kind of. Have you ever seen how big those cables are? The neighborhood.
If you cut it from the cable line to the house, I mean, it's just...
The cable line to the house is just, yeah, that's the little one, but the ones that go... This one here is probably, I don't know, a 2-inch cable. And they're usually pretty deeply buried. The only reason I know it, they had to dig one up in one of the neighborhoods I was in. Huh? Okay. SONET, Synchronous Optical Network. This is usually going to be a high-speed telephone network. This is one that, you kind of know the terms. Are we ever going to get connected to one? Probably not. The multiplexers, and the reason I say, look, you can see the speeds here for the SONET, the OC standards. We go up to 39,000 megabits. That's 39 gig, right? So those are relatively quick ones, fast ones. Wireless, 802.11. Everybody using that, right? Probably in some form or other. 802.11a, b, g, n, and now 802.11ac is the next standard, which you can, it's in draft form, and they actually build some equipment. It's not cheap, but you can buy AC access points and AC NICs if you go to the Best Buys or H.H. Gregg and those guys, but they are still relatively expensive. Put this one in, so it's kind of the evolution of speed. If we go here, first generation, we're all the way up to 2 megabits per second in the wireless world. Second generation, 11. Third generation, 54 meg. 11N, 450 meg. Has a theoretical of more. The 5G, the next one, we're talking, the AC, we're talking gigabit speeds over wireless, which is pretty good.
When you have 3G on your phone, that's 3 gigabits.
Nah, it's third generation. This is wireless generations, not telephone. This is 802.11. The spectrum, just to see where they are, yes, there are only 3 true usable channels. So if you go home and somebody's on channel 2, the only thing they've done is just mess up 1 and 6 for you. Because I know there are 11 of these things, actually there are more of these things, but you can only get clear channels because of the bandwidth that's required. You actually overlap multiple channels. So when you look at your wireless 1, 6, and 11, look and see what everybody else is on. If they're on 1, go to 11. If they're on something, I mean, if you get them spread out so that you don't get the interference. And the 5 gigahertz spectrum is down here. It's got a lot more channels on it. Higher frequency, higher data rate, shorter distance. WiMAX, this one's kind of interesting, and also one of those that's expensive. And I look, there isn't one here. There is a wireless provider, B2X, but they don't advertise the speeds that WiMAX has, up to 70 megabits per second. And the 70 megabits here, 72, it says line of sight 30 miles, but that's for a point-to-point connection. Point to multi-point, say 6 miles and 40 megabits per second. It's like everything else. Oh yeah, we can go really, really fast and really, really far, point to point. But if you do other things, but I don't want to go point to point, I want to connect my 8 sites together. I want to point to multi-points. You're going to go less distance and lower bandwidth.
Even if that's the case, so if you're connecting to someplace else, you're suffering by their capabilities.
Yeah, well, you're always going to get the lowest common denominator in these things, typically. And that's why we go through all these, when you set one up, when you're trying to buy something, what's the best for you, because actually what's available and then what's the best for you. In Roanoke, most people could probably get cable, DSL, or wireless. Which do you want to pay for? Which do you want? And then you got all of the smartphone capability. If you want to tether it, that's another possibility. Although the people that do that say that the internet connection's really not all that grand on those.
I guess it depends on
All right, but boy, how long is it going to take you to download a DVD, a copy of a legal DVD,
it depends on
a backtrack, copy of backtrack, the gigabyte of that.
Who downloads the legal DVDs? Who does that?
You will when you get into security because they're open source and they are available. How long is it going to take you to download backtrack, which is about 1.5 gig?
Depends on if it's the first time you try to download it or you've been using this service.
What he's saying is it cached or not, right? Yeah. But you still got to get it the first time at some point.
Yeah.
Yes, that's convenient, but I don't think they're really all that fast, are they?
Not.
Yeah. Satellite, what was I say? Satellite are there. Satellite, the problem with satellite is delay. Most satellites now are two-way. Originally, they were telephone request, www.whoever.com. You would send out a telephone, and then it got downloaded to you via the satellite because that link was faster. So it was up with phone and down with satellite. Now I think it's two-way up and down. Problem is delay, and there can be significant delay in these things because they are, even though they say they're low orbit, they're still about 30,000 miles in space. Geosynchronous. Satellite frequencies, and those are just there. I've never, just as a certification testing, I've taken just to see what was on it a couple times the Network Plus. I've never seen anything like that on it. This is kind of an interesting chart. What the technology is, the typical media, and then what the throughput, the maximum throughput, not what you would necessarily expect to get. Because when we talked about the wireless, the maximum throughput was 54 megabits per second. Well, can you expect to get about half of that? Just because of the way that wireless works. Remote connectivity, PSTN, XNet25, ISDN, however you're going to connect with something, and now VPNs across the internet in order to get someplace remotely. Dial-up software, if you use that, credentials, we're going to do that, and we'll go through this. When we do a couple of the other ones later on, you'll set up different types of VPNs so that you see how those things work. Remote access servers, routing remote access, effectively becomes an endpoint. What we would do, can't resist, you know that. If we had that, we had our, I still can't draw a cloud. And we have a routing and remote access server, and behind it, routing and remote access, routing, you can think router here. This is just a server that does that. Back here we would have maybe a switch that goes to the different resources connected, and then we're out here, we're going to go through the cloud by whatever connectivity, dial-up, VPN, ISDN, wireless maybe, and you could, whatever it is, we're going to connect to this device. This device will then give us an IP address. See how it does that? That's on this network here, so that we can now connect to it. You like it?
Is that how you could get to like your remote desktop?
Yes. And then we would run a RDP, and we would have to, then we would run remote desktop through that.
Without having your own server, how would you go about doing that?
You can do that with a VPN. If you want to go from one to the other, you can create Windows machines, you can create a VPN connection between two desktops, or a server desktop, whatever, and then run that protocol through the VPN.
So if I had somebody else's
If you had somebody else's laptop, you go here and they're on the other side of the cloud, and they have a router and you have a router, right?
Mm-hmm.
You would create a VPN connection, and then you could remote desktop through that VPN connection. That creates that's a virtually private. That's a direct connection between you and them. We'll do that in the Windows classes. We'll do that in the Cisco classes. So remote connectivity is a big deal. What we do, what we do here is run a piece of software called Secure Shell. Let me go back to this thing, give you another bad drawing. Let's use blue this time. We have a server. It's not talking to me today, right? A server in here that has a open SSH on it, which is just a piece of software, obviously. And it is listening on a port.
That's a straight line, though.
Let me try the other pin. Let's try this again. The other one wasn't even talking to that. Wouldn't even change colors. So we have this software running here, and we have our firewall, whatever you want to call it, just something here. That we have a firewall. It has a port open. This thing is running on a port, and let's say it's running on port 10,000. Doesn't really matter. And we poke a hole through the firewall. You have a client machine out here that then connects to this address that's netted through that port here, and then you can create a remote desktop through that SSH connection, Secure Shell, which is maybe a little bit easier to do. Secure Shell is an open source free piece of software that you can run. You can get the server and the client. You have to have one of each in order to make it work. Routing remote access, the server to act as a router, multiple security provisions, and again, when we get into the Windows stuff, we'll set up some of that. The virtual machines actually run through one of those already when we do that, as we do those. See, they have a much prettier picture than I do. But whatever you're using, you still have to have an endpoint to connect to. And you have to configure your firewall to allow connection to that endpoint. So those are things that we'll do. Serial line internet protocol carries only IP packets, asynchronous transmission. You're only going to see that in a wide area network connection, probably on the router. Point-to-point protocol is the common one when you're working with different router manufacturers. If you're doing that, Cisco says you're going to have to use this to get to some commonality. Each of them optimizes their own. They become proprietary. Point-to-point over Ethernet, typically going to be used for DSL. It's an Ethernet encapsulation of the point-to-point protocol. RDP, how do we do these things? And this is a nice kind of relationship to the OSI model. RDP, the stuff that runs on the computer, is going to be at the application layer. TCP, IP, in order to get to the points down here, and then what kind of encapsulation are we going to have. Point-to-point over Ethernet, you notice, is a layer 1 and a layer 2 protocol. Remote control allows the user on the client computer to control another computer. Remote access and remote control are two terms that they love to throw out many times. Configured to allow access. The host allows the clients a variety of privileges. What you're really doing there is just sending images back and forth. Remote desktop software for Windows relies on the RDP protocol. It's an application layer protocol. It's available on all of the Windows machines, and as long as you turn it on, and by the way, if you want to remote desktop, it's normally off by default now. It didn't used to be, but now for security measures, you have to go and actually turn it on and say who can connect remotely to an individual machine. Simple to configure, like, yeah, just put in the IP address. Terminal services, Telnet, I think we looked at that a little bit. In one of those, I telnetted to the switch. A terminal service that we can control a device at that layer. It's another one that's not turned on by default. Telnet's not turned on by default in Windows anymore. You can either be a client or a server. You can just turn it on to telnet out, or you can turn it on to where you can telnet in both directions. What you'll do in Windows, if you telnet, you're going to get a command prompt at the remote site.
Get a command prompt?
Yeah. Yeah. You guys did all that in the DOS, right? All that command prompt, Windows DOS? Yeah. We get really accustomed, I digress, accustomed to all this nice GUI stuff in Windows, which is really, really cool unless you're trying to control, 400 or 500 machines. Then you really need to know how to do the command prompt stuff and how to script, and batch files and things like that are the first step in being able to do that kind of scripting. For instance, if you were going to make, I'm really digressing now, 300 users, how long would it take you to make 300 users using the GUI?
The second one?
No, 300 different users.
300?
Yeah.
GUI, I don't think.
Go and make a new user in a Windows machine. How long is it going to take you to make 300 of them?
A long time.
A long time. I'll go along with that. What if you can script it? You know how long it takes?
Even longer?
Less than a minute.
Really?
Oh, yeah. If you do it to command line, it doesn't take very long.
Oh, because all you can...
Also, you've already got a database.
Mm-hmm.
What we do here is you get the stuff out of campus, you get it as a text file, actually a comma separated value file, and then write a script to take the information out of that database that somebody already created and make users out of it. Takes about a minute or less than a minute to make the users. It doesn't really take that long to get the data set up either, because you only need certain ones of them. Terminal services, a number of certain terminal server, Citrix MetaFrame. Citrix is probably the first in the virtualization or application virtualization, allow you to run things. Thin client is a workstation using terminal services. A thin client is a device. I'll bring one in. I'll go get one at the break. All it is a little bitty thing. It's got no hard drive. It's got a NIC. Usually a Citrix client.
Like a wise unit?
Yeah, like a wise unit. And it connects, it runs all of its information, finds all of its information, runs all of its applications at a remote server. All these people up front here and financial aid all run in the Citrix client. They've got desktops, but they don't really need them, because all of their applications run out of Virginia Beach using a Citrix client. All their applications just show up there. If we had appropriate thin clients, that's all they would actually need, because they don't store anything on their machines. Everything is centrally controlled up there.
If you had like a virtual server, you wouldn't even need it.
Correct. You wouldn't need any of this stuff. For our virtual machines, do we need all of these really fancy computers? Are not really fancy, but all of these. No, all you need is Internet Explorer or a remote desktop, if you know the IP address, if you can connect to it. And that's all part of those thin clients. And usually, again, the Citrix client, because most of them are focused on Citrix in order to do that stuff.
Don't use those
A lot of them do. I think a lot of businesses are afraid of them, and if you do that, you have to run a Citrix form. You have to. Everything has to be on servers, and you have to buy the Citrix software and the Citrix client. What Citrix really does is a really cool shell to run remote desktop for Windows. Do you really need it? No, you can run it all through remote desktop. It's not as pretty. But I think a lot of them are afraid of it. A couple of them do. Some of businesses around here do. A number don't. There are some advantages because you've got now a true centralized backup, because nobody can store anything on their desktops because they don't have a desktop. They don't have a hard drive. So you have to store it on the server. That way you can back everything up. And it can become more efficient, but your servers have to be reliable in order to do that. Simplifies data sharing and databases, shared databases, stuff like that. Web portals, web-based interface and application. It's just using a different protocol to access something, to run different ones. VPNs, virtual private networks. Traffic's isolated from other traffic. I'll make one more, and I think this is going to be the last bad drawing that I do today. What a VPN does is if we have two endpoints, now it can be, this is going to be what's going to be called a tunnel. You can also have one called transport mode. You can go from computer to computer, which I was talking about earlier. This one will go site to site, and we always draw these really cool tunnels, like you're going directly there, right? How many routers do you think are between any 2 points?
Depends upon where you're at, though.
Depends upon where you're at. How about on the internet?
Well, a lot.
You ever looked at how many routers are between us and the Roanoke Times, for instance? Like 16, because you can't go directly there. So what we're really talking about here is an encrypted transmission. What we do is on our backside private network machines, they would send information up here. Let's say this is 192.168.1.0 network. My 8 didn't work so good, did it? And this didn't work at all there. 192.168.2.0 network. If I want to go from the 1 to the 2 network and I have this thing set up, say, hey, we'll encrypt the data that goes there, it goes up to this device and says, oh, I've got an access control list. If I'm going to the 2 network, and this is what happens with your financial aid information, that network, those stations get encrypted going to Virginia Beach. Do you think that the traffic that goes to Virginia Beach on that frame relay through the to go into the Moodle server needs to be encrypted?
No.
No, so it goes on the regular connections. So what it does is gets encrypted here, it gets a new header put on it. It gets encrypted and it gets a new IP address put on it. And the IP address, the destination is going to be this guy, and the source is going to be this guy. So it says anything going from this network, put it in this tunnel, encrypt the data, and send it to the other end. Once it gets here, it gets decrypted and then gets sent to its destination private IP address. If it's not on the access control list, the list that says encrypt, then it gets sent through a regular connection, unencrypted connection. You don't want to encrypt everything because it does take a lot of resources to encrypt stuff. So it has to be encrypted and decrypted at the other end, and it does take some significant amount of processing to do that. So what these are for, to have a private conversation and a public network, so that we can send stuff over the internet and keep it private. Is it going to be protected forever and ever? No, it's encrypted. Can encryption be cracked? Absolutely. Is it going to take some time to do that? Yes. So that's why we do those things. Virtual circuits, virtually private network, point-to-point tunneling protocol encapsulates PPP. We have Cisco. Windows has PPTP and layer 2 tunneling protocol, 2 different tunneling protocols that are available, and each of them has different capabilities. Encryption, authentication, and access depend on what you want to do. Sometimes you don't want to encrypt everything. You only want to be able to verify that the other end's who they claim to be. Told you we were about done. Last bad drawing. So what's the difference between a LAN and a WAN? The protocols. And we're really talking mostly at layer 2. Sometimes we go down into layer 1 to do these things. WANs, yes, all the things that you said early on, go farther, usually go farther and go slower in a WAN, are all true. Local area network confined to a building or set of buildings, campus typically, absolutely. But when you get down to the technical definition, LANs are in the 802 arena, and WANs are other protocols, the frame relays, the asynchronous transfer mode, those kinds of protocols. Star topology, we looked at that. Star, rings, bus, mesh, each of the topologies. The WAN topology is not radically different from the LAN topologies. PSTN, the telephone network, POTS, POTS, or PSTN, the dial-up system. X25 is analog. Frame relay is the digital rendition of X25. The new and improved X25 is frame relay. ISDN connections, we looked at those. I think you need to know about them. I'm not sure that you'll ever really see one, because why would you go to something that expensive and that slow when you can get cable for probably half or a third of the price, honestly? And a number of businesses use cable, use Cox services, things like that. Or you can use the things like there are other providers in the world, other ISPs in the world. DSL, phone and data over the same line. Broadband cable, dedicated, and of course you can get voice on it too, voice over IP. SONET, the high-speed WAN signaling, typically get telephone switching networks for those things. WiMAX, up to 70 gigabits, the 2 to gig frequency range, and these are theoretical. The gig is real. The 10 gig is, I think, is still theoretical in those. Data remote access connect, a number of ways to connect. Dial-up, however you get on the internet, VPNs, those types of things, and then use the terminal services or the remote desktop services in order to do what you need to do. VPNs are popular because they're cheap. Doesn't cost you anything. If you send out a bunch of salesmen, they have to update a database. They can get in their hotel room, connect through the VPN to the server. They don't have to, have to pay phone charges. In the past, you had to have a modem bank and you had to dial up and do those things. Now you can use an encrypted connection that gets back to the headquarters or wherever they're doing things, and then you can get onto the private network. Advantages and disadvantages of that. What's the problem with letting people on the private network? Any viruses that they have are now on your private network. So you be careful about who you let do those things and what kind of control you have over the machines. But wide area networks, yep. Internet's the biggest one. There are others available, and you'll do some of those. When we get into the routing, you'll set up some wide area networks. Questions? You probably just want me to be quiet and sit down, don't you?